For this lesson, we will further explore the domain of a rational function. So the domain of a rational function just tells us all of the x values that we can plug in order to make the rational function work, essentially. So the only time that we are going to have a restriction on that domain is when that bottom or denominator is going to equal 0. So to restrict the domain, the easiest thing to do is to set the denominator equal to 0 and solve for the resulting equation, and then that's going to be the value that you can't use. So the domain is every value except those that we find in step 1. So let's take a look. This one should look familiar. We've looked at it before. Find the domain of x. So I'm going to write x minus 3. I don't really care about the 2. X minus 3 equals 0. I would add 3 to each side and get x equals 3. Now, often what my students do is they will tell me that the domain is x equals 3. And that, of course, is not true. What we have just found is the value that the domain cannot be. So I would write this maybe in a couple of different ways. If I were writing it in set builder notation, I would say the domain is all of the x's such that x is a real number and x does not equal 3. So it's a real number, but it doesn't equal 3. If I want to write that in interval notation, that one's going to be a little bit trickier. I know that any number is going to work. So all of the numbers from negative infinity all the way up to 3 will work, but 3 is not included. So notice that open bracket means we're not including 3. In addition to that, which means a union, I can go from 3 all the way up to positive infinity. So essentially I'm saying I can use any number that I want, but 3 is not included. Let's try this one. I'm going to set 2x squared minus 11x plus 5 equal to 0. So for this one, obviously it's a little bit harder, but we've dealt with this with polynomials and how to set them equal to 0 and how to solve. So I know I'm going to end up factoring that. So you can certainly factor just by the guess and check method, which is what I'm going to do. If you can't do it that way, then you should certainly tic-tac-toe to find that result. So you can always double check 2x squared minus 10x minus 1x. That would give me my minus 11. So that's looking good to me. So now, again, I'm going to set each of these equal to 0 and do as much mental math as you would like. So 2x equals 1. So x equals 1/2, which essentially means x cannot be 1/2. And then x minus 5 equals 0. I would add 5. So x cannot equal 5. So those are the two restrictions. To write that in set builder, again, I would write all of the x's such that x is a real number. X does not equal 1/2. Oh, almost wrote negative 1/2. And x does not equal 5. Interval notation, going to be a little bit longer process. I'm going to say from negative infinity all the way up to 1/2, not including either one. From 1/2 all the way to 5, not including either one. And from 5 all the way to infinity. So essentially I'm saying not 1/2 and not 5. Everything else is okay. If I set x squared plus 9 equal to 0, I can't really factor that because it's not a difference of squares, so I get x squared equals negative 9, and if I take the square root of each side, I get x equals plus or minus 3i. Well, I know that those are imaginary numbers, and that's not going to restrict my domain. So the domain is all of the x's such that x is a real number because there's no restrictions, or negative infinity to positive infinity. There was no restriction because there's no value I can plug in here to make that 0, no real value. Try this one on your own, then press play to see how you did. Again, I've got a polynomial, and that will require me to be able to factor that. So I'm going to factor this into x minus 4, x plus 2. Again, I was looking for numbers that multiplied to 8 that subtracted to 2 or had a difference of negative 2. So if I set this one equal to 0, I get 4, and this one equal to 0, I get negative 2. In set builder notation, I would say all of the x's such that x is a real number, that x does not equal 4, and x does not equal negative 2. Whoops. And in interval notation, I would say negative infinity all the way up to negative 2, union, negative 2 all the way up to 4, union 4 all the way up to infinity.